Hey guys, these are some notes on 7.8. We're kind of jumping ahead because this is a pretty cool rule and it's used for end behavior. So why wait until later in the year? And it's called LHopital's rule. That's French for the hospital. And you might be wondering why this was named that. It's from the person he got named after, this sweet looking dude right here. Guillaume Francois Antoine Marquis de l'Hôpital. So he's a French mathematician. He worked with intermediate limits, or indeterminate limits. He had very poor eyesight, but he didn't let that affect his sense of style. Check that out, right there. And then he was friendly with other calculus giants, Leibniz and Bernoulli, and he may or may not have been the inspiration for the Whig political party. So pretty cool dude, and I think you'll like him even more once you find out what L'Hopital's rule is. Alright, and here's what L'Hopital's rule is. He found out that if you ever have a limit as x approaches c, remember c is for constant, so any number, that of f of x over g of x, if you ever do that and you get 0 over 0 or infinity over infinity, remember how many times that happened? Well, the punchline of L'Hopital's rule is if you ever get 0 over 0 or infinity over infinity, which are called the indeterminate cases, it means you don't know what the limit is and you have to do something more, then it also equals the limit of f prime of x over g prime of x. I know you're probably mad because you know how many problems we did earlier this year that limits turned out to be 0 over 0 or infinity over infinity, and you had to do tons of work like factoring and canceling and all that stuff. Well, this would have worked too. But before you come after me with pitchforks and stuff, it only works if you have a fraction one. So you're going to see, remember how last lesson we were doing all those problems with top heavy and bottom heavy and all that stuff? Well, anytime you see a fraction, you can also use L'Hopital's rule with this, and you will get the exact same limit. The correct answer limit that you would have gotten here if you were able to reduce it and stuff. So let's try this out, and you'll see it's kind of nice. All right, so here's a quick example. So first thing, I don't know, maybe you want to distribute this just to make your life easier. First thing you would do with this problem is try plugging in a 3. So if you plug in a 3 to the top, you have 6 minus 6, also known as 0. Plug in a 3 at the bottom, you square it, you get 9 minus 9 is 0. So when you see this, you're like, oh, since it's a fraction, I could just use L'Hopital's rule. And instead of having this original function, I can take the limit as x goes to 3 of the derivative of the top over the derivative of the bottom. So let's do it. Derivative of the top is just 2, right? If you did this, you would have had to do chain rule, ninja rule. You don't want to do that. So take the derivative of the bottom, you just get 2x, right? And now you plug it in again. So where do I plug it in? You put the 3 right there. So it's 2 over 2 times 3. And this would have been a problem you'd have to factor and cancel and then plug in, and you get the same answer, right? Also known as 1/3. So there's the limit. That's kind of cool. So L'Hopital's rule is kind of handy in that fact. Now, here's a question you might have. What if I do this and I plug it in and it's still 0 over 0? Well, L'Hopital's rule is repeatable, so you can just do it again, and do it again, and do it again, and do it again, until you don't get 0 over 0, or infinity over infinity also happens sometimes. So we'll take a look at another example. All right, so here's a second example. This is a problem. I'm sure you remember doing these. You'd have to get the conjugate and do all sorts of brutal stuff to this, right? Well, you're going to dislike me now because there's an easier way to do it. L'Hopital's rule. I don't know. We just learned in that order. Remember, it's like taking a hike. Okay, so on this one, you plug in a 0. Cool, so square root of 4, right, which is 2 minus 2 on top. You plug in a 0 on the bottom, you get 0 over 0. Oh, time for L'Hopital's rule. Now, be careful, because 0 over something or something over 0 would not mean you're using L'Hopital's rule. Okay, you'd actually get an answer of 0 or infinity. Okay, so what's L'Hopital's rule? L'Hopital's rule means take the derivative of the top and take the derivative of the bottom. Well, the bottom's going to be pretty easy, right? So let's start there. Let's do the easy part first. Derivative of the bottom is just 1. Derivative of the top, not as easy. So I want to rewrite this as 4 minus x squared to the 1/2 power minus 2. Okay, that minus 2 is going to go away in a second, but let's do it. So the derivative of the minus 2 just makes it go away. Derivative of this is a ninja rule, remember? So you put the 1/2 in front. So you take the old power in front. Remember, the second time you write it as it was. Don't change the inside. Then you subtract 1 from the old exponent, so negative 1/2. And then the last trick is the ninja, and that's the derivative of the inside. So the inside was 4 minus x squared, so the derivative of that is negative 2x. That's a lot of stuff. Now, it might help you if you rewrote this. Remember, anything with a negative exponent goes to the bottom of the fraction. And same with the 1/2. I can put 1 on top and 2 on bottom. So I'm just going to clean this up and say, okay, the negative 2x is definitely hanging out top. The other stuff, the 2 from the 1/2 goes down, and this whole thing, because it has a negative exponent, goes down. But now it has a positive exponent. Okay, that's a lot nicer to plug a 0 in, because what happens on top? You get a 0. Now you might be worried right now, is the bottom going to be 0 too? I don't know, let's see. You put a 0 in here, and you get 4 minus 0, right, to the 1/2, which is also known as the square root of 4. That's 2 times 2. It's not 0 over 0. 0 over 4, which is a limit equal to 0. So remember, the only thing bad is 0 over 0. That's when you got to keep going. All right, so example 3 here. Just wanted to show you another one. So in this one, you try plugging in a 0, and you get 0 on top, 0 on bottom. Okay, cool. So L'Hopital's rule applies, and it says I'm allowed to put in, I'm allowed to take the derivative of the top, which is 8x, and the derivative of the bottom, which is 9x squared. And then you plug in it again, and the top is 0, and the bottom is 0. Uh-oh, got to do it again. And that's the cool thing about it. If you had to do it 5 times, you could do it 5 times, because it's not like these are really hard derivatives. It usually doesn't take that long. Derivative of the top now is 8. Derivative of the bottom is 18x. Okay, and now if I plug a 0 in, you get 8 over 0, which is not 0. Please don't say that. It's infinity. You do have to check, is it a positive infinity or a negative infinity? That's a positive number. So it's a positive infinity. Okay, so if that would have been a negative 8, it would have gone to negative infinity. Alright, so I wanted to show you one that came to infinity and that you had a 0 over 8. Remember the previous problem, you had a 0 on top, and that also ended the problem. The only thing that keeps you going is 0 over 0 or infinity, which might make you wonder, how could you get infinity over infinity? That would be if you had something like this. Right, something like that. If I put a 0 on the bottom here, it would make it infinity. If I put the 0 on the bottom here, it would also be infinity. So that would be a problem you'd start doing L'Hopital's rule on until you couldn't anymore. So anyway, that's just a cool little trick. Anytime you get limits, just know you can also do the derivative of the top and the derivative of the bottom. Don't forget the stuff we learned before, because a lot of times that common sense way we learned in the last section works just as well and sometimes faster than L'Hopital's rule. But when in doubt, 0 over 0, infinity over infinity, L'Hopital's rule will work. All right, people, that's it. When you work on the worksheet, look back at these notes. All right, talk to you later.